Sitting at home, bored and got nothing to do? You're so bored that you got out your old GTM textbooks and you got stuck at changing coordinates on a manifold? Well, I'm here to save you. Soon you'll breeze past this and be calculating tangent spaces and one-forms in no time. That's right. Break it down, bitches.
We want to understand how the coordinate basis vectors, the partial derivative with respect to the variable xs. I evaluated at the point P, change under a change of coordinates. That is, we want to express these vectors in terms of the new coordinates x tilde at the point P. Learn the definition of coordinate, the fields on a manifold, the partial derivative with respect to the variable xs. I evaluated at the point P equals the differential of the inverse function phi at the point phi p acting on the partial derivative with respect to x of I. Evaluated at the point right. Now we want to understand this vector in terms of the new coordinate track, so we compose the identity map as the identity fraction on set m is equal to the inverse of psi followed by the combination of psi and the inverse of phi. The derivative of the composition, I'm an ocean side of Iyengar. I'm evaluated at per k. Pi to p and apply to the partial derivative with respect to x at the pi. Out of u equals partial derivative of 10 days with respect to x at I of p times the partial derivative with respect to tilde x at the point psi of p. Now substitute this into the earlier expression. At the point P, the partial derivative with respect to the variable x raised to the power of I is equal to the differential of the inverse function sine evaluated of psi of p multiplied by the partial derivative of the transformable of the form tilde raised to the power of j with respect to x raised to the power of I the form pi of p. Then taking the partial derivative